7th grade math test 29 study guide problem number 1. We have to find the measure of angle R, but I see that those three angles make a straight line. In other words, they are supplementary. So when angles are supplementary, you add them together to equal 180. One of them is missing, so we use that variable they gave us R, and we just solve this equation. When we solve equations, we combine like terms, and then we isolate the variable. When I start to move things to the other side, that's when I do the inverse operation. I don't do inverse up here. We're on the same side, I add them the way they are. When I move it to the other side, that's when I do the opposite of what I see. So that angle has to be 38 degrees. Number 2, we're going to solve this equation. We're going to work farthest away from the variable first. We're going to do the -7 first. So I'm moving it to the other side, so I do the opposite of -7, which is to add 7. And so it's gone. 7 plus 7 is 14. Now I got to get rid of the 2. 2 times y, or 2 next to y, the opposite of times is divide. So I divide 14 by 7. 14 by 2, and I get the answer is y equals 7. So for number 3, it says Marcus hikes at a rate of 3 miles per hour. If he hikes for 7.5 hours, how many miles will he hike? Anytime they're talking about distance, we use distance formula. And distance can always be found by multiplying rate times time. Distance equals rate times time. That's a formula that we absolutely have to memorize for many, many of our math classes. So distance equals rate times time. I read it again and see what they give me. They give me 3 miles per hour. And we learn that per hour, they give us 2 different units of measure. That makes that a rate. So we have the R. 7.5 hours, well, hours is obviously time. And they say how many miles, or find the distance. So I plug in the numbers for the letters that they give me, the values for the variables that I have, and I just solve for the missing variable. But the variable's already isolated, so all I have to do is multiply these two. And when I multiply these two, I take 7.5 and I convert it into a fraction. I convert 3 into a fraction by putting it over 1. So 2 times 7 is 14. 14 plus 1 is 15. Now normally I do my factor trees and cross out my 1's. But there's only a 2 down here, and I know neither one of these numbers have 2 in it, so I just multiply. That's a reduced answer. But if I'm saying 45 over 2 miles, it doesn't make a lot of sense, so this is an appropriate time to convert. Even though that's a simplified answer, we're going to convert it. So what I do is I say 2 goes, I divide, it goes in and out. 2 times 2 is 4. Subtract, bring down the 5. 2 times 2 is 4. That's the most number of times 2 can go into 5. And once I hit the end there, I can bring that remainder up top, keep the same divisor down there, keep the same denominator. So my answer is 22.5. But 22.5 what? 22.5 miles, because the rate was miles per hour. That's why it's miles. Next problem. Number 4, they say the height of a tower on a scale drawing is 16 centimeters. The scale is 2 centimeters per 21 meters. What's the actual height? So we have a scale, or a rate, of 2 to 21. So the question is, if that's our scale, then what's 16 centimeters is how many meters? So I can write a proportion, because these are proportional relationships. That's what scale drawings are, scale factors. That's how you use them. So I put centimeters on top, centimeters on top. Down here, this one should say meters. Sorry, that's a little typo there. Meters on the bottom down there. And then I just cross multiply like we've been doing all year. Cross multiply and divide. And I get 168. But 168 what? 168 meters is the answer. Number 5, angle Q and angle R are complementary. Well, that means when you add them up, it equals 90 degrees. So if angle Q is 35.7 and we don't know angle R, I write this equation here. I isolate angle R by doing the inverse operation of a positive 35.7. Remember, when you're subtracting these over here, make sure that you line up your decimals. So go off to the side and do that, and pause the video and make sure that you have what I have here. And your answer should have been 54 3/10 degrees. So next problem, number 6. You have a diagram to look at. So they say, name the angle that's supplementary to angle DOB. Well, for angle DOB, I start at D, then I go to O, then I go to B. So that's this angle right here. Now, supplementary means make 180 or make a line. The only angle that makes a line with DOB is BOA or AOB. It's the same one. So the answer for that has to be angle AOB, or you can say BOA. You just have to make sure you put the O in the middle. Number 7, we're going to find the area of the triangle. Well, triangles are just base times height divided by 2. So I go 11 times 13 divided by 2. 11 times 13 is 143 divided by 2. Remember, I go in and out when I divide. So the 143 goes in, the 2 goes out. You can take your remainder here, put it up top. Your divisor is going to be your denominator. And you have 71 1/2 or 75.5 units squared is the area for that triangle. So for problem number 8, we have another triangle. And again, it's still base times height divided by 2 for the area. But what's confusing is they give us expressions, and they also give us a third side. So when you're finding the area of a triangle, it doesn't matter how it's shaped or where it's orientated. The area, the numbers you would use to find the area, you would have to use the sides that make a right angle. You see the right angle down here? So base and height have to be perpendicular to each other. So I couldn't use 6x. I have to use 6 and x plus 2. So 1/2 base times height, or base times height divided by 2 would look like this. The base is x plus 2. Look on your diagram. Make sure that makes sense to you. That's the base. The height is 6 because they're perpendicular. And then area of a triangle means divide by 2. So to simplify this expression, I can distribute first. I believe this is the easiest way to teach it to you. So I go 6 times x is 6x, and 6 times 2 is 12. Now, if you're dividing an expression and you have a plus sign, that's just like distributive property, because remember, multiplication and division are related to each other, inverses of each other, right? So, in other words, I'm going to have to divide both. If you got a plus sign here, you got to divide both. So I put both of those over 2 and simplify to get the expression that represents the area. If I knew what x was, I can give you one number, but since I don't, this is the expression that represents the square units or the area for that triangle. For number 9, we have to find the perimeter of that shape, and all I'm going to do is go all around the outside of that shape and add up all those sides. So take a look at your diagram right now and make sure that you follow along, and you have these same numbers. You're just going to add all. See, I'm starting on the top and I'm going clockwise around it. You should have all these added up. Look at the diagram, make sure that makes sense where all these came from, and then all you're doing is simply adding these together. Now, since we're not using calculators on this test, let me show you a quicker way to add these up. So this is what I would do. I would go ahead and look, how many 12s do I have? I have 1, 2, 3. So 12 times 3 is 36, okay? And next is 9. How many 9s do I have? I have 1, 2 9s. Again, this is not how you have to do it. I just think it makes it a little easier, so you might want to try this. How many 3s do I have? I have only 2 3s. I have 1 18, and I have 2 6s. So instead of adding up all this super long list, I'm just adding up this shorter list. And when I add these up, I'm looking for my 10s, right? So I'm looking for numbers that make 10. I know right here 8 and 2 make 10, so I have 10 in my mind. And this is 12 and 8, that's 20. 20 and 10 is 30, so I put my 0 here, I carry my 3. I got 3 plus 3 is 6, 7, 8, 9, 90 units. Notice it's not 90 units squared because perimeter is a linear distance. It's not how many two-dimensional squares to cover it. That's area. And that's what we're going to do next. Now we're going to find the area for this diagram. So what I'm going to do, this is not the only way to do it. This is just one way to do it. I can just go ahead and horizontally separate these into 1, 2, 3, 4 different rectangles. So this top rectangle here, to find the area for that, and that's what I'm going to do for all 4 and just add them up. Area is base times height, so it's 12 by 6, so I have a 12 by 6 or 72 square units for that top one. Now let's go to the second one. This looks like 12, doesn't it? But it from here to here is not 12. All the way is 12. So what I have to do to get this distance from here to here, I look that the whole thing is 12 and this part's 6. So I know this looks like more than 6, that's 6, but you never assume that anything's drawn to scale. You go and you find out for sure. You don't assume by how it looks. So if this is 12 all the way and this is 6, then what's left over down here is 6. So this is a 6 by, all the way across is down here 18. So that second rectangle, make sure, pause the video and look at this yourself. Make sure this second rectangle, you see why it's 6 by 18. So 18 times 6 is 108. So I have 72 square units here, 108 square units here. Now we're going to do the third rectangle. This is 3 by what? Well, all the way across is 18. But this part I don't need, right? So 18 take away 9 is 9. So this is a 3 by 9. The third section is a 3 by 9. That's 27 square units. And the last section I can see is 3 by 18. So those are the 4 sections I divided into. Yes, there's other ways to do this. And then we just add all these areas up, and we get 21 units squared. So the volume of any rectangular prism is length times width times height. And they're talking about a concrete block, and they give us 3 dimensions, so we can assume that it's a rectangular. No, did I say prism? Yeah, that's right, rectangular prism, right? Oh, sorry, my mind just blanked out there for a second. So, anyways, yeah. So this is a box-shaped concrete block, or rectangular prism. So we're going to multiply to get the volume, those 3 dimensions they give us, and that's all you do for that problem. Make sure you use units cubed, since it's volume. Alright, number 11. Number 11, they start talking about distance, rate, and time again. So again, we'll always use distance equals rate times time for those problems. It says Jerome went on a hike. He climbed 3/4 of a mile. That's a distance. So we have D this time. In 2/3 of an hour. So they didn't say something per hour, so that the hour is just time. What is the hiking speed? So we got to find the speed. Well, speed is the same as rate. So we, like I said before, we plug in the numbers they give us. They give us distance this time, and they gave us rate. We have to find the R, or the rate of the speed. So they gave us distance, they gave us time, and we have to find the speed. So if I were to rewrite this to put the, remember we put the coefficient or the number first, and then the variable or the letter second. So if we were solving this, we'd know we'd have to divide both sides to get rid of that, because next to means times. But it's a fraction. So how do we divide by fractions? Well, we learned in class we can get rid of that by multiplying by the reciprocal. So when we have a fraction in front of a letter, we flip it upside down and multiply both sides, because that makes this become 1. And 1R is R. And if we isolate R, we know what R is, or we answer this question. But we have to go over here and multiply these 2 fractions to get 9/8. Remember, factor trees, cross out your 1s. We're going to find out that that's already reduced, but you can convert it to 1 1/8 miles per hour. Remember to go in and out. So for 12, we have a proportional table. So what I can do is I can take any 2 points and write a proportion. They're all going to equal each other, right? Y over x is going to equal y over x for all of them. So I'll pick the first one, the one with the smallest numbers, and I'll put 23.2 over x over 1. And then I'm going to use that to find this missing number here. So since that's missing, I'll use a variable and then put that over 3. So here's my proportion that I can use to solve this. And then, as always, we cross multiply and divide, except for when my coefficient is 1, I don't have to divide because 1 times y is already y. So I'm done there. Okay, so here's an example of the multiplication. If you forgot how, pretend there aren't any decimals, right, and add them in the end. That's how we multiply decimals. So 13, it's another proportional question. They're saying if you have these 2 equations, are they proportional? So what you can do is just write a proportion and see if it's true. And what's true for all proportions is this, is that this times this, or cross products, should equal this times this. If that's true, it's proportional. Another way you can do it, if you see this is 3 times bigger, this one has to be 3 times bigger as well. If that's true also, then it's proportional. So however you want to do it, either one of those 2 ways will work. 14. 60 is 40% of what number? So anytime they talk about percent, we use percent proportion. Percent proportion is over of equals percent over 100. Since they gave us percent, I put it over 100. Since they said 60 is, that 60 goes on top, not on the bottom, because it is over of. And as always, we cross multiply and then divide by the coefficient to get our answer, and 150 is our answer for number 14. Okay, so 15. 15 says a factory produces 23,000 computer monitors per day. The manager of the factory claims that fewer than 990 defective computer monitors are produced each day. So that's the claim. So whatever we find out, it has to be less than 990 out of 23,000. So they took a random sample to see if it's true, because they can't test all of them, it takes too long. So they took a random sample. They sampled 230 computers. They found that 2 of those were defective. So the question is the sample that they took less than their claim? So if their claim is 990 out of 23,000, then what we can do is check to see if the actual sample we took is less than this. That's our goal here. Okay, so what we can do is then take each one. So we'll take the original. If I'm going to divide this by this, as always, it goes in and out, and we learn in class we can take a shortcut. When you got zeros on the end, you're dividing, you just hit those, right? It's like dividing out of 10 for each one. So it makes it a little easier. So I'm going through and I'm dividing this. 230 doesn't go into 9 or 99, it goes into 990, so that's why I start right here, right? I multiply 230 times 4, subtract, drop 1 down, and then, you know what, I'm only going to do 1 or 2, because that's really all I have to do. I'm just seeing what this is about percentage-wise. So they're saying less than 40% are defective. So let's take a look at the sample and do the same thing. If it's 2 out of 230, 2 goes in, 230 goes out. And I start to divide this, 230 doesn't go into 2, or 20, or even 200. So when I start dividing, my first number is going to go here. I automatically know this number is smaller than this number. So the sample was smaller than what they claimed, and that's what they said. They said, no matter what you do, it's going to be less than this, and that's true. It was less than this. So for 16, it says, based on a sample survey, a company claims that 80%, okay, so they're talking percents again, so we're going to use percent proportion, is over of equals percent over 100. It says 80% of the customers are satisfied. Out of 1,285 customers, how many would be satisfied? So in other words, we're going to find 80% of 1,285. That's why the number goes on the bottom this time, because it is over of. We're finding 80% of this number. So I plug that number in. Again, cross multiply and divide. Dividing by 100 is easy. We move the decimal 2 times to the left, and we see that it should be 1,028 customers. 17 is a probability question. It says if you roll a number cube or a die 48 times, how many times do you expect to roll a 4? Well, the probability of a 4, there's 1 4 out of 6 sides, so the probability is 1/6. So out of 48 times, what I can do, if the probability is 1 out of a total of 6 tries, that's going to be how many out of a total of 48 tries. In other words, I can write a proportion. Cross multiply and divide again, and we see that it should be 8 times. 18 says a coin is tossed and a single die is rolled. What's the probability the coin shows tails and the die shows 6? Well, the probability of tails is 1/2, right? There's 1 tail out of 2 sides, that's why it's 1/2. Probability of rolling a 6 is 1/6, because there's 1 6 out of 6 total numbers, or 1/6. If you're going to do both in a row, that's when you multiply your probabilities, and you see there's a 1 out of 12 probability. Or if you had to, you convert that into a percent by dividing top by bottom. Okay, and next, 19. We're going to solve this equation. So we always simplify this side first, and then we isolate. And simplifying means to distribute and combine like terms. Now, we don't have to distribute here because there aren't even any parentheses. So I'm going to combine like terms. I'm going to use teams. Negative 2z plus 7z. Remember, you can't add z's to constants. You can't add letters to numbers with no letters. So I add these up. There's more positives than negatives. That's why it's 5x. And now I solve this equation. So we work farthest away from the variable. We do the opposite of what we see because we're moving it. When they're on the same side, we don't do an opposite. You notice I didn't add 2z to 9z? I don't do opposite because they're already on the same side. It's when I move them that I do the opposite. So, and how do I get rid of the 5? Divide both sides by 5, and I see the solution to this is x equals -3. And the last one, we're going to simplify this expression here, and we're going to say which of the expressions given are the same. So again, distribute first, but there's nothing to distribute because there are no parentheses. So we combine like terms, but before we do that, we have subtractions here. So we're going to make our subtraction into addition problems. That way we can use teams. So like we've been doing all year, add the opposite, add the opposite. I add all my g's up, and I add all my constants up. So if I use teams here for the g's, I have 8 positive g's, 4 more positive g's, and 2 negative g's. I'm going to combine all my positives, I got 12 of them, and all my negatives, I only have 2, and then subtract, because opposite teams we subtract. And then I ask myself who has more. These guys have more, so the answer is 10G. Now over here, the 2 and the negative 2, those are opposite teams, so I subtract, which is 0. So I have 10G plus a 0, or just 10G. That's the answer. All right, 7th grade. I hope that helped.